Good afternoon and welcome to NASA headquarters in Washington. I'm Cheryl Warner in the Office of Communications. Looks like we have a really great audience today, and I'm not at all surprised because we have two special guests for you today. We are going to talk to two astronauts who recently returned to Earth after 168 days in space. NASA astronauts Mark Vande Hei and Joe Acaba were members of Expedition 53 and 54. Aboard the International Space Station, they helped conduct more than 250 investigations. This research is important not only to those of us on Earth, but it's also helping NASA with its exploration goals in going back to the moon and ultimately Mars. So please join me and give a warm welcome to NASA astronauts Mark Vande Hei and Joe Acaba.
Honestly, that was such a warm welcome. I feel like I just showed up for a game show. Yeah. So we're going to talk to you. We've got a 16-minute video, if I have my facts straight. And then we've got some time for question and answers, which is the most fun part for us. We've seen this video a few times, but we haven't heard your questions that many times. So if it's time, let's do it. All right, so what you see is a crew of three. It's our Soyuz crew is Joe and I, and Sasha Mazurka, the commander. And here we're doing one of the ceremonies we do in Kazakhstan before we launch and getting up the steps to the rocket.
Yes, so launch from Kazakhstan, it's a pretty exciting time. It takes us 8.5 minutes to get from Earth to space. So we get from 0 miles an hour to 17,500 miles an hour in just a little over 8 minutes. So you can feel that acceleration as you get going. And here's the shot of the launch.
You can imagine when you're standing in the desert, it's very quiet, and then all of a sudden, you can feel it in your chest as this vehicle starts going up into space. But once that rocket stops burning, you suddenly get that surge forward in the seat as the rocket cuts off, and for the first time you feel like you're in space, and this is what the view's like out the window.
Yeah, it's not too bad. It's a pretty cool view. And it took us about 6 hours to get to the International Space Station. So depending on where it is when you launch, it might take you 2 days or 6 hours. This is what it looks like as you approach it. So it is pretty amazing to see this beautiful laboratory. You can see the engines firing. Everything is automated if it goes well. If not, the commander can take over and fly it manually. You see some of the antennas retracting. And then we're going ahead and docking with the space station.
And that probe that connects with the space station gets actually retracted by a mechanical device pulled in until we get latches connected. And after some leak checks over a period of a couple hours, we're finally able to open the hatch. You can see that probe is now retracted back in. And after being in that small space for a long time, we're very happy to finally get out.
That's why you always see the smiling faces when astronauts come out of their Soyuz. It's tight, and we'll show you a picture a little bit later that it'll really illustrate how small it is. And this was Mark's first flight, and so he's been happy the entire time. As you can see on that picture, it was pretty cool.
Of course, the whole reason we're up in space is to do science. There's lots and lots of different science facilities on the space station. This particular one is a combustion facility. We just have to, honestly, we're not scientists. Astronauts aren't really scientists. We serve as laboratory technicians because other people do the data analysis. We just get to float.
I mean, our background is we're all scientists as a background, but
True.
Our job on board is more as a lab technician. This one in particular, again, is looking at fire and flames, how they behave in space. We have Mark here was doing a demonstration. He's trying to see how an IV will actually work in space. The air and the water, the mixture, it's a little bit more difficult to separate the two, so that's why he's doing his little dance here, is trying to separate them and showing off his nice skills.
Dancing on bungee cords.
And one of the payloads that we had was called Veggie, and it's looking at how plants grow in space. If we want to get to Mars and beyond, we're going to need to know how to grow our own food. So you can see we had a pretty good harvest. They gave us the opportunity to cut some off and enjoy them for dinner. And so after being up there for a while, having some fresh lettuce was pretty tasty.
Absolutely. It's definitely an international crew. We've got a U.S. segment and a Russian segment, and our international partners on the U.S. segment as well. But we do science on both sides. So Sasha's over here working on the U.S. segment, and this video is Joe and Sasha working together to work on spheres. You may have heard about it. It's a experiment done with MIT students that helps us see how the algorithms they write work at controlling satellites. Because if you let go of something in the space station, it's in an orbit around the Earth.
And then sometimes we just want to take cool pictures. So had nothing to do with the experiment, but it looked cool.
One of the unique facilities on the space station is an equipment lock on the JAXA module, the GEM. And I got the opportunity to put together some satellites. We loaded them on a slide table in there. This is faster than normal speed here, which is time lapse. Got that equipment outside the space station, multiple robotic arms grabbed onto it, and eventually we were able to put those into orbit outside the space station. And as if you didn't already appreciate it, of course, the view outside is absolutely incredible.
Yeah, being in space is pretty fun. It's got quite the killer view. Apart from some of the other science, we're also science experiments. We're still learning how the human body reacts in space, so we'll take blood samples, urine samples throughout the mission. We have a super, super cold freezer that we can put those samples in, get them nice and frozen, and then when we have a vehicle that's returning back to Earth, we'll put those in there and get them back to the scientists that can then analyze those samples.
After about 2-3 months on board the station, it was time to change out part of the crew. So we're seeing Randy Bresnik, a Marine NASA astronaut, changing command with Sasha Mazurkin, a Russian person with Air Force experience.
Godspeed, Expedition 54.
Keys to speed.
Of course, we're definitely a very cohesive crew, and it was hard to see your friends leave. But only 3 days later, we had other friends arrive.
We changed them out for a new set of crew members, and it really is an international space station. Of course, we flew with the Russians. We had an Italian astronaut with us, and you can see we also had a Japanese astronaut. So it was a great experience throughout.
We had lots of visiting vehicles, 2 SpaceX Dragon vehicles and 1 Northrop Grumman Cygnus spacecraft came to visit us, so along with Russian Progress vehicles, and those are the only ones that are transferring cargo. Of course, people coming and going as well. So the space station actually acts kind of like a port. What you see here is one of the Dragon spacecraft coming. If you weren't already aware, we have to reach out and grab the U.S. cargo vehicles with the space station's arm, which, as you can imagine, is a very intense moment in the career of an astronaut.
Yeah, so Mark got to do that, and it is stressful. After all that work, it all comes down to him flying the robotic arm, and he did an awesome job. Once he grabs it, then the mission control takes over. They attach it to the space station, and then it's our job to take the cargo off and put cargo back on. Here is the Cygnus vehicle. This one burns up in the atmosphere when it comes back, so it's like it brings the supplies up, but that's our trash vehicle. So you can imagine having 3 or 4 months of trash building up in your house. It is nice to finally get rid of it.
Now we're switching back over to Dragon. This unloading Dragon, you can see how much easier it is to transfer heavy cargo when it all floats. You don't want to make it go fast, though, because that means you have to apply a lot of force to stop it.
So if you're giving it to your buddy, it's kind of fun. You just throw it really fast and see how he handles it, because they don't know how massive that object is. But you get really good at using your feet to float around. It becomes very natural. This is what it looks like in the process of unloading it, and then we completely filled it up. And here we have the Russian vehicle that also comes up and brings us supplies. They're usually pretty good to us, and we get some fresh fruit and vegetables on those, so it's nice when they come up.
And unlike the U.S. cargo spacecraft, just like the Russian human spacecraft, the Progress docks autonomously. Don't have to reach out and grab it.
So we had some pretty good luck in that we had 5 spacewalks during the entire time we were up there during 53 and 54. You can see people getting ready to go outside. It takes about 4 hours just to get you ready to go out and do the spacewalk that then lasts 6 or 7 hours. So it does make for a very, very long day.
It's an amazing environment. Of course, it feels very familiar, even though the backdrop is very different when you're in space. The mock-up of the neutral buoyancy lab of the space station is so good that we felt like we were on very familiar territory when we were outside. The spacewalks we did were largely focused on upgrading parts or replacing parts of the robotic arm, including lubricating that. Had a great view, and I had to sit there for 2 hours facing down at the Earth while I was lubricating that thing. And it's a team effort, though. Here we're on the arm, but Paolo Nespoli was operating the arm, and there's some time-lapse photography of that effort coming up.
It's an interesting feeling when your feet are in a foot restraint, your hands are free, as you can see there, and now you're being moved across to get to the right location. But you can see how big the space station is with Mark there on the end of the arm.
I earned some good points with my wife when I put "I love you, Jules" on my cuff checklist.
See, he's very smart. You know, he's sweet.
I try. And here you see we're manipulating a bag. One of the tools we have on our bodies that we get really good at using is a body restraint tether. You can use it to hold yourself in place by attaching it to the station, or hold something to you as like a third arm on your body.
So living in space can be interesting. We have to do all the things that you do here on the ground, whether it's washing your hair, shaving, getting a haircut. It's just you're in a different place, and so you do things a little bit differently. When you get the haircut, you have the vacuum cleaner right there, so we can suck up all the hair as you go. We also spend about 3 hours every Saturday morning, everybody getting together and cleaning the space station, which is what Mark is doing there. But we also like to have fun. Pizza in space.
The our Italian crew member Paolo Nespoli was giving us a hard time last week about having too much meat on that pizza.
I like the meat lovers. And you just use a pair of scissors to cut it up, and it was a nice treat after being up there for a while. We were fortunate enough to have a lot of holidays while we were up there, Thanksgiving, Christmas, and New Year's, and it really was a time for all the crew to come together and share some special time. And now we just have some shots of the Earth that we'd like to share with you.
If it's possible to crank up the volume on the background music, it's kind of nice for this. Caribbean looks amazing from space.
Never got tired of looking at Africa. The colors of the desert were just incredible.
We're going around the Earth once every 90 minutes, so we got to transition from daylight to night, or vice versa, every 45 minutes roughly.
And if you turn off all of the lights in Note 3, where we have our big window, you get these incredible views at night where all the humans decided to live. You get the moon reflecting off of the water. You can see lightning at night. It's really impressive and moving.
Of course, we have the northern or southern lights. In this case, we're flying over Europe, so those are the northern lights in the background.
Yeah, when that happens, it's a good day. It is fun to watch.
Every day, we have 2.5 hours of exercise scheduled. Here you see me working on the resistive exercise device, getting ready to start working out. I called it resistive exercise device because lifting weights when all the weights would float doesn't make a lot of sense. So we use vacuum cylinders to provide that resistive force.
But it does. It feels like you are lifting weights. You can do a wide variety of legs exercises, upper body. So we do this to maintain our muscle mass and bone density. We also have a treadmill that you have to wear a harness and use a bungee cord, otherwise you would float away. And when you look at it on the space station, it's actually on the wall. So you can imagine running on the wall, but you can't tell. It all feels the same. And then we have the stationary bike where you clip your feet into the pedals. No seat required, no handlebars required, you just pedal.
After spending 168 days on the space station, it was time for us to leave. Again, we left 3 people behind, and Sasha is now turning over command of the space station to Anton. Those gentlemen that you see in the video on the right side there just returned a couple weeks ago.
Yep. So now they're finally back, and we give our hugs goodbye. It's kind of bittersweet. You're leaving your buddies behind, but you're happy to get back home to your family. And so we'll hop in. They'll close the hatch behind us, and then you'll see how cozy we are inside our nice, comfortable Soyuz.
Especially because there's always a few more items you want to add to bring home, because that's one of the few ways we have to bring stuff back to the Earth safely.
So if you don't like small spaces, you probably don't want to fly in a Soyuz vehicle because it's comfortable, it's cozy.
Undocking feels kind of like a pop. It was very, very easy because we actually just undo those latches we use to connect us, and then there's spring pushers that push us away. Only after we're a safe distance away from the space station do we actually start firing those thrusters again to change our orbit. We've got to wait till we get to the right place over the planet before we actually do a deorbit burn and then start interacting with the atmosphere like you see here.
And that's a good thing. Things are burning up around us, which is intentional with the heat shield. And then you have your parachute open, which for me is one of the most violent parts of the entire landing. Mark liked it because it told him that we were going to live because the parachute is open. And once it opens up and you get past that initial kind of swinging around, it is a very kind of quiet time as you get closer to the Earth until you actually hit the Earth, and then it wakes you up a little bit.
It's a very, very hard impact. I was surprised. I thought, how would I know if I have a concussion? But we were all fine. No problems there.
So obviously it was wintertime when we landed, so it was cold. Helicopters landing. The Russians did a great job arriving before we actually landed, so they were there right away, and it was just a great feeling. To open the hatch, you got that cold air hitting you. We have an opportunity to call family and friends, let them know that we're okay. Then we go from there, we hop on a helicopter to the nearest airport that puts us on a plane to Houston. So within 20 hours of landing on Earth, you are back in Houston, Texas. So it's quick. And we do that intentionally because we want to get back as soon as we can so they can take samples from us and we can conduct some of the science experiments. So we want to get us back as soon as we can to make that happen.
And we're all feeling a little wobbly at this point. We're trying to fake it like we can walk really well, but we're using a lot of concentration.
I wasn't too good at faking it. It takes a little bit of work.
Thanks very much.
Well, you guys, that was an amazing presentation. Thank you so much. I think I have a better idea of what it's like to be up there. And I'm sure we would all like to be there with them.
Yes.
So with that, I'm sure you've inspired a lot of questions from our audience here. Before we get started, I just want to let folks know we do have 2 microphone handlers in the room. So please raise your hand and we'll bring a microphone to you. So wait for the microphone for your question. And for the brave person that asked the first question today, I'm actually going to give you one of Mark and Joe's patches.
Whoa.
So please raise your hand and show us your questions.
Oh man, there's a lot of takers.
In space, didn't you have to take like all the juice and stuff like that out of the food so bacteria couldn't get in it?
So we have, it's a great question. The question, as you heard, because he was using a microphone, thanks. So we have thermal stabilized food. It's a lot like for those of you who served in the military and MRE, meal ready to eat. We also have dehydrated foods. Basically, we have to have a long shelf life for all the foods we send up because it tends to be in stowage for a while. The Russians actually used a lot of canned food, and that was quite tasty.
And then when we get these visiting vehicles come up, they will bring us some fresh food, but we have to eat them fairly quickly.
That's correct.
Hi, my name is Janelle, and this is Josh. We work at the Challenger Center,
All right.
and we're working on Krista's lessons and videos that were being filmed. And we just wanted to know what you admire most about Krista's legacy and how you would potentially like to see that translated into these lessons.
Well, I think she had a huge impact on a lot of people, myself included. Being an educator before I became an astronaut, you don't know how many people that I have talked to that remember her enthusiasm, for space exploration, but also for education. So it really was an honor for me while I was up there, and Ricky Arnold, who is there now, to kind of bring those lessons back to life, not only to inspire the students that we have today, to kind of have that same enthusiasm that we had, but also to highlight the teaching profession. I mean, she was a great symbol of what an educator is, what educators are capable of doing. So it's a wonderful time for us to start that back up again and highlight all of that she did. Thanks. Thanks for what you're doing.
Hi, my name is Pierre Bernasa. Welcome to Earth.
Greetings, Earthlings.
Yes.
I'm curious about when you were planting the lettuce and the vegetables, do you use some type of soil from here, from Earth, or some different substance? And also if you use some kind of fertilizer or just naturally organic quotation?
Farmer Joe's got that one.
Yes, I became a farmer. So we actually had what they called pillows, these little packets, and it had a medium in there, so it was acting as the soil. And in there, it kind of had these time-released nutrients, and so everything was self-contained. All I had to do was not kill them, and so, you know, I had to water them, and it was kind of stressful because you don't want to be the dude that, you know, killed the plants. I mean, it's kind of a big deal. So
At least not until we ate them.
yeah, until we ate them, then we kind of didn't kill them, but anyway. So we just had to add water to them, but everything was self-contained. And what's interesting is we had the artificial light, and so the plants, without gravity, they grow towards the light. We also kept, once we did harvest the plants, we kept those pillows because they want to look at what the root structure looks like in that microgravity environment. So we didn't get to see those because they were inside. When we left, they were still on the space station, frozen, so they can come back. So it'll be interesting to see if there is a change, and all of that will help us as we design new systems when we go ahead and travel to different planets.
And just to correct something I mentioned just now, for those of you who have grown lettuce, you know that you don't necessarily kill the lettuce when you eat it. So they kept growing.
We didn't kill it. It's a family show.
Hi, my name is Steven, and I just wanted to know, like, do you keep your rockets going in space? And if so, how do you keep them going if there's no air out there?
Great question. So here I go. I got to teach physics, so I love this topic. Basically, when you're in space in orbit, you are falling towards the Earth. The reason you don't hit the Earth is because you're moving so fast horizontally that you keep missing it. So we don't have to keep the rockets firing. We just keep falling. And that's why it looks like we're floating, because everything's floating at the same rate, and it seems very gentle and uniform. However, because we're close enough to the Earth, we do interact with the Earth's atmosphere, and over time, that orbit will very slowly degrade. So periodically, we have to do a reboost and get the station's orbit adjusted back to higher enough so we continue to stay where we want to be. Did you have another part to that question? Did I answer it? Perfect.
Mark, this is Kevin back here from Wisconsin, physics teacher. So this
is to you.
Yeah, that's for Mark. At the end of the semester, end of the school year, I always ask my students, because they have expectations coming in, and I know that NASA trains you, and you're already expecting things. What was the aha moment that you had, or the thing that struck you that went, I didn't expect this?
So there's aha moments that were positive and negative. I'll give you one of each. One, I'd say the aha moment that was uncomfortable was when I got to space. It felt a lot like someone was holding me up by my feet, because there's a fluid shift. We're a whole bunch of different objects connected in this body. The fluid is normally getting pulled by gravity towards your legs. Well, if you're constantly falling, that fluid is floating along with you, and it tends to shift towards your head. So I felt very stuffy all the time, and that sensation like you'd feel if kind of you're 45 degrees head down is a little bit like what we feel. You just can't get your head back up, though. So that felt uncomfortable to me. Another aha moment for me that was positive was when I realized, so when we train for spacewalks, we're underwater. That means if you're, and they do a really good job of trying to simulate the environment and as well as they can to simulate weightlessness. But if you're moving yourself in water, you start moving yourself, and the water drag will cause you to stop. So you get very used to, in the hours we train, to starting your motion and having to keep applying force to move it. In space, my tendency was my muscle memory was start yourself moving, get control, start yourself moving, get control. So I was basically starting myself and stopping myself. when I realized because of physics, I have to just very slowly get myself moving and then just make sure I'm still going in the right direction. I really shouldn't have to keep working to keep myself moving. So that was a positive aha moment for me.
How long does it take for you to get from space to the ground?
Yeah, so I think the overall process is about 4 hours from when you push off of the space station. And the reason is we orbit the Earth and we want to make sure we're in the exact right spot before we fire the engine that slows us down and then allows us to enter into the atmosphere. Once we fire that engine and do that, what we call the deorbit burn, it's about 45 minutes, I think, from that point until we hit the ground.
Okay. Hi, I'm
hello.
Lexi. I'm an intern here at HQ. I was curious if there was anything that, like any changes that you had to become used to when you came from the space station back down to Earth? Because I know that there's videos of like people putting things in the air and they just drop because of gravity, things like that. What was the biggest change, I guess, when you came back down to Earth?
Readapt to the Earth's.
Yeah.
For me, wow, the biggest thing to readjust to.
I didn't drop anything.
I didn't either. I didn't drop anything either. I do remember feeling like, wow, it's really uncomfortable to bend over just to tie my shoes. Well, actually, and the very first thing that I ran into that reminded me that, wow, this is different from being in space, was to get out of the Soyuz spacecraft. Like we saw, it's very tiny. In fact, it's so tiny that only the person in the middle can actually get out the hatch. And if I want to get from the left or right seat to get into the middle, the hatch can't be open because it's too big. You have to get it out of the way, so you close the hatch and then you move over. So Sasha Mazurkin left, and then Joe left, and it was finally my turn to get outside. The hatch was closed again. I leaned over to get into the center seat, and I just fell over. I did not. My head felt so heavy that I wasn't used to balancing like I am right now, and I just kept going. Once I fell over, I got a little okay. My pride was hurt a little bit, nothing else. Then I sat back up, and then I had to stand up to help the search and rescue folks pull me out the rest of the way.
Yeah, you do wonder, how do we live on this planet? Because when you get back, everything is heavy.
It's so
your
hard.
Arms feel heavy, your head feels heavy. You're like, how do we do this? But it's very quick that the body once again adapts, and now you just feel like you've never gone. But it's interesting when you first get back and you feel gravity at work again on you.
What is the coolest part about being an astronaut?
The coolest part about being an astronaut is going to space. That is a cool part, but it's a very small part of being an astronaut. I've been at NASA since 2004, and I have around 300 days in space total. So it's a small part of what we do, but floating around in space is totally cool. The view is awesome, so I would say for you young folks that are out there, if you get a chance to go to space, do it, because it is awesome.
Yeah, and I can't do a backflip on the ground, but I can do a mean backflip in space.
You could try one. You don't want to try it?
How do you get the water from Earth to space to water the plants?
We recycle a lot of our water. In fact, we try to get every bit water, quite honestly, water vapor, sweat, urine. We recycle all that stuff and we drink it later on. Sounds bad, but it's undetectable as anything but really good water.
And we do send, the Russians will have in their Progress vehicles, they'll have tanks that are full of water, so we'll do that. And then if we have engineers that are always looking at the water balance on the space station, so if there's a need, we can send it up. But water's heavy, it's expensive, and that's why we try to recycle as much as we can. And I think it's over 90% of the water, we're able to use that again. So it's a pretty neat closed system that we have up there.
Hi, thank you for speaking with us today. Acknowledging that there are many, many young people here that have many big, important academic and professional decisions, far ahead for them. If you could speak just a bit, when did you know that you wanted to be an astronaut? And is there any particular professional or academic highlight you can speak to that, really helped you get there? I recognize you're at the pinnacle of your careers, and it's a really long and hard road, but you are also a shining demonstration of what hard work, determination, and education can get you.
Whoa. Go for it.
So I always thought astronauts were really cool. I never thought I was cool enough to become one. So it just didn't seem realistic to me to have that as a life goal. I didn't know what I wanted to be when I grew up, but I knew I was pretty sure that when I figured it out, I wanted people to believe I could do it. And so looking back on things that I might have done as a young person to set myself up for success or keeping this door open was I said yes to a lot of challenging things. So that's one thing that I would put out there. And then honestly, there's thousands and thousands of people out there that would make fantastic astronauts that never got the opportunity. So I just feel like I was very fortunate as well.
Yeah, for me, growing up, watching film of the astronauts walking on the moon was pretty inspirational, and I thought that was cool, and I would love to do that. I love to read science fiction. I like to watch all these crazy movies about going into space, but I never thought, that was something I would be capable of doing. So I didn't know that I really wanted to be an astronaut or that it would be real until I was teaching, and somebody told me that NASA wanted to hire some educators to become astronauts, and I go, wow, this is pretty cool. So I went online and I looked at the qualifications, and I'm like, well, I've done that, I've done this, and I just went ahead and applied like you would for any other job. And did I think I was going to get hired? No, but you can't get hired if you don't apply. And so I went ahead and it worked out. So I would tell people, like Mark said, find those challenges, keep pushing yourself. When opportunities come up, you kind of have to grab them and go after them, and just kind of believe in those dreams and what you can do and push yourself. And then in terms of what should people study, what should you do, I would say it doesn't matter. Of course, to be an astronaut, you have to have a degree in science, engineering, or mathematics, but find something that you really, really love. The chances of becoming an astronaut are pretty slim, but Mark and I both loved our jobs before we became astronauts, and that's super important. So find whatever you love and work really, really hard. You don't need to be the smartest person out there, but there's no reason why you can't work harder than everybody else.
Thank you. Like he was a teacher.
Yeah.
Hello, my name is Lorenzo. I'm so excited to be here today. Such an honor. I had a couple of questions. So one, is there a dress code on the ISS? What's that like? And also, are there any fashion trends?
Actually, it's funny you say that, because between the two of us, we kind of had something going on. Joe's a pretty fashionable guy, and I'm not, so I tended to follow his lead.
So clothing is required. That is part of the dress code. But, we have clothing. The clothing has to be practical. You're on the space station, and you are working. So most of us wear some type of cargo pant because things float around, and you don't want to lose them. And so you might have batteries in this pocket, you've got a pen over here, you've got scissors back here, and then usually just a t-shirt, a polo shirt, something that is comfortable to work in. Obviously, if you're going out and doing a spacewalk, you have a certain dress code to do that. If you're going to work out, you have a dress code for that, shorts and a nice shirt that you can work out in.
Largely because that's all that's available.
And but in terms of fashion, he gives me credit, but we're both not too fashionable. I had my, I come back and people tell me about my Joe Hawk, but that was not a fashion statement. That was, we didn't have a good barber, so it was just cut the hair.
And I would say, actually, Joe and I on weekends during the work week, we chose to just wear long pants because it felt more professional. On the weekends, we'd wear tank tops and shorts just because we had some, and we didn't have to wear the same clothes for the entire week, every day of the week.
What's it like to throw up in space, or have you ever?
What was the second part?
I only heard, what's it like to throw up in space? What was this?
Have you ever?
So luckily, I have not had to throw up in space, but I would say that, about half of the astronauts do not feel great when they first get to space. So when I go, I always have a barf bag on me because I'm right at the edge of having to get sick. And for me, it was the same way when I came home. I didn't feel good. But luckily, I was just right there on the edge. So I did not, but I was kind of ready for it. And we have some pretty good barf bags that we can use if you have to get sick. But it's obviously not a comfortable feeling, but you got to do it. You got to do it.
Everybody's different, and the medicine that I took beforehand worked really well to keep me from having any problems.
What was it like to adjust to zero gravity?
Where are we looking? Oh, there we go.
Okay, so I'm the newest guy, I was the only rookie when I first arrived at the space station, so I was the only one who had to adjust. It was very humbling, I would say, because a lot of things that I do subconsciously, we all do subconsciously, suddenly took a lot of conscious effort. And we all had very intense jobs, and I felt like I just kept making mistakes. So again, I'd say it started off feeling very humbling. My crewmates would say I would just tend to be hard on myself, and
he did good.
They were all looking out for me.
Except when his legs were kicking all over the place.
Yeah. You got to learn new habits, I would say. Things that, for example, I'm just standing here. It's taking me no effort to stand here. But when I first got to space, I found myself hooking my toes under a handrail to keep myself there. But then I'd pull up on my toes, and that would make me pitch forward. And so then I had to plant my foot here. And so then I'd find myself pulling up harder on my toes, and I'd push harder on my leg, and I was fighting my own body. And I was, wait a minute, just chill out. And I'd relax, and I'd stay in the same place. Or another time I found myself on the ceiling at work. It's really nice. You can just flip upside down, stick your feet in the hole. But because mentally I was upside down, I was pushing my legs like I was going to fall to the floor if I didn't push hard enough. Same thing. And I said, wait a minute, this should work if I just relax. And I relaxed, and I stayed in the same place with very little effort. So those type of things took some getting used to for me.
What was it like when you were sleeping and eating in space?
Yeah, so sleeping in space is the best. For all the old people in here, and I see a few of you there, the beds become more and more uncomfortable as you get older. You've got little, hot spots, the bed's just not quite right. But in space, you're floating. And so we use sleeping bags, and we attach them to the wall, not because you have to, but if I fall asleep right here, not inside my sleeping bag, in the morning, I might wake up in a different, module. So you kind of want to stay in the same spot. And different people might tie it down more or less, but really you just get in the bag. We have little holes in the sides you can slip your arms through. And it's kind of funny to watch people sleep because, your arms are they kind of float up. So it's kind of scary and weird to see somebody sleeping, but it is super comfortable once you get used to it. So I got some of the best sleep ever.
Yeah, and at first, it felt weird to me to try to sleep when I wasn't pressed against something. That's how I was used to sleeping. So at first, I needed to have my sleeping bag really tight to get that sensation. But after I fell asleep while I was watching a boring training video in a module and was just drifting across the module, when I woke up, I was, wait a minute, that was really comfortable sleep. So I went back to my sleeping bag. I only connected that to shoulders so that I wouldn't hit my head on anything when I moved around, and it was super comfortable after that to sleep.
And I think the second part was about eating in space. The human body is pretty impressive. I mean, the digestive system works the same. You can eat, and that was some of the things when we first went to space. You're going to be able to eat up there, and everything works fine. So it's good.
You feel full faster when the food's floating in your stomach, though.
Hi, I'm Andy. Really excited that you're here. I can imagine that when you're in outer space and you see you're visually in outer space and you see the world, a lot of cosmic or spiritual questions come up, like are we alone, or physics questions such as, where are black holes, do they exist? I'm wondering if you had any cosmic insights while you were in outer space, anything that you learned or any epiphanies out there?
You want to start?
No, go for it.
Okay, so the thing that struck me the most, it was just a different perspective about the scale of the universe and how all of the human beings that I've ever seen were in this thin layer on the outside of a rock, is kind of what it felt like. So I was really struck the first time I looked at the Earth from space, how when the sun was shining on the Earth, how completely black everything out around it was. So it made the Earth seem very, very, very isolated. Then the next thing that I noticed when I looked at the horizon, all the biggest mountains didn't show up. I could see this thin layer of the atmosphere, and I'd see the shape would be a little changed just by really tall clouds. But those are really tall. Those huge terrain features like Mount Everest, they're ridiculously small compared to the scale of the Earth. So the Earth looks very smooth. And so with that idea that's just minuscule on the size of this big Earth, and everything I know and love is in this minuscule layer, just seems really strange to me. And then finally, I'd say, coming back to the Earth after looking down on the Earth for so long, from the outside of the atmosphere looking down on it, being inside the atmosphere looking up, it's very apparent to me that all of us, when we're outside, are separated from the vacuum of space by only a bunch of air molecules. When I was in space, I was separated from the vacuum of space by a spacecraft. So we're really in space. It's just we don't think about it that way. So that was a big thing for me.
Yeah, it's an interesting perspective, and to borrow a phrase from our Italian astronaut that we were with last week, he had a phrase that was, for me, pretty important, where he said, we look at the Earth and we think, okay, we got to take care of the Earth, which we do. But he said, it's not the Earth that is fragile, it's our existence on the Earth that is fragile. So we need to take care of that planet, our planet, for our own existence. And like Mark said, when you see it from a little bit farther away, that just really drives home that point.
Joe, if I can address my remarks to you, there are people who are here from the building next door, the Corporation for National Community Service, which supports engaging Americans in service, and I came to visit your program at Dunellen Middle School with the Florida Learn and Serve program.
Awesome.
And part of the reason I think, and you said that you were chosen, well, you said it's because of the great programs you're doing at that school. So I'd like to say, just on behalf of the Corporation for National Community Service, thank you for the great work that you did down here as well as up there, and we're very proud of you.
Thank you very much.
Hello, my name is Max. My question would be, how long do you think the International Space Station could stay self-sufficient without like a transport of materials and food?
So right now, we're looking at the space station, funding for the space station that goes through 2024. So you have that aspect of, how long do we want to support it, which hopefully we'll extend that out. But when you look at what's amazing is it's about 20 years old, and the space station is in really, really good shape. We have a lot of spares on board for things that break. So I don't see a fixed number on how long we can keep it there, as long as we can resupply those important components that we need.
But I think what you're asking is, if we cut off all resupply, how long could we continue to maintain the space station? So I know we have am I right in thinking we have 6 months of food?
We always maintain at least 6 months worth of food, so that might be our most limiting factor for humans.
And I think routinely we adjust the orbit on the order of a month, once a month or so. I don't know what would happen if we had to wait 3 months, for example, to do that. But we're talking on the order of months, I would think, before we have concerns.
That's a good question. So it depends on what factor you're looking at. Is it for humans to continue to live without anybody touching it, or is it without any communication with the space station from mission control?
And even the reboost, we've already got a spacecraft up there docked to it, and it's got its own boost capability autonomously. So I don't really know how long that can last before you need to provide something else to provide that propulsive capability. It's a great question. I just don't know the answer.
Thanks.
So if the International Space Station catches on fire, what would you do and what would it look like?
The question was a really good one. How do we react to a fire on the space station?
Well, we trained for it. So a lot went into the design of the space station so that a fire doesn't start. From the material that is used, both in the wiring and all of that, material on the outside, on the walls. And so hopefully a fire will not start.
And then real quick about the physics behind a fire. On the Earth, when you see that characteristic shape of a flame like a candle, the reason it's got that pointy end at the top is because those hot combustion gases, when you're in an environment where there's an up and you got buoyant forces, go up and away, which pulls in those oxygen-rich gases to keep the fire going. In space, which way would those gases go? Those hot combustion gases, there's no buoyant force. Everything's in a free fall together. So they tend to just make a ball around the flame. There's nothing to cause the oxygen-rich gases to come in. So it's kind of hard to keep a fire going.
And so if a fire does start, hopefully some of the automated things like cutting off power, that will happen automatically. But if we see a fire, let's say a battery catches fire, we have fire extinguishers. We have some that have water, that you actually spray a water mist, or we have CO2 if it's behind a panel, and we can go ahead and shoot that in there. So we would, if there was a fire, try to figure out where it is, cut off power to the fire. If that doesn't work, then we would go ahead and fight it just like you would here on Earth. We just can't call firefighters to come and do that, so we got to do it ourselves.
Which is one of the fun things about being an astronaut. You pick up a lot of different skills along the way.
Yeah, we're plumbers, we're firefighters, we do it all.
We got to fix the toilet for sure. So the other thing about the response to a fire is one of the automatic responses to shut off all the airflow. Because like I mentioned, the fire is not going to create its own airflow. We don't want to have a fan blowing across it to add oxygen inadvertently.
When you were communicating with like other astronauts from different countries, like what was the main language? Because you would all speak different languages.
The official language of the space station is English. Because we launch in a Russian spacecraft, we have to learn how to speak Russian because on that Soyuz spacecraft, we're talking with a Russian control center and we're speaking Russian. The tendency is that we jokingly call it Runglish. If I'm speaking to a Russian, I'll speak Russian to him. He'll typically respond in English, and that way we keep it at a nice, simple level so we can all understand.
Yeah, it was fun being around the dinner table, and you've got these different languages going on. And what's interesting is sometimes there's a word that you just know it more naturally in Russian. So I could be talking to Mark, and I'll throw out a Russian word just because it makes sense to both of us. So it's an interesting thing to watch.
Like there's a word prekrit that's in Russian. That's the word we used if we're responding to a depressurization emergency. We would close the hatch a little bit, basically. We don't have a word for close the hatch a little bit, but the Russians have this word prekrit. So we would never say close the hatch a little bit. We'd say prekrit, even if it was the middle of an English sentence.
My name is Faith, and I wanted to know what's your favorite part about being in space?
Well, so growing up, I love like superheroes, comics, and all that. Anybody here like that stuff? Like Superman, Spider-Man? Yeah, don't be afraid to say. That's cool. So in space, you can do that. I mean, I love just pushing off the wall, and you're flying. You kind of feel like Superman. We'll talk about we probably shouldn't do this all the time, but we'll fly like as fast as we can. And then you grab onto a handrail, and then you can spin around, and that's just like what Spider-Man does when he goes ahead and shoots his web out there. So for me, that's just, the kid in me just loves that part about being in space.
I also love looking outside the window and taking pictures because it's such an amazing view. The only way I would be able to share it with other people was to take a lot of pictures, but it really doesn't do it justice. It's hard to share how amazing it is.
Hi there, I'm Josh, and it's really fun to be here. Thank you for an amazing presentation. My question is about the data that you said was collected when you got back to Earth. Were there any surprising results? And then the second part of my question is, are there any plans to incorporate artificial technology systems into some of the data collection on the ISS?
So I'm leaning towards saying the scientific process, the data collection that happened, it takes so long to figure out what the result, to analyze that. So we're probably a decade too early on finding out what really came out of our particular flight.
Yeah, and some of the things they're looking at, for example, is we all know that bone density gets affected while we're in space. We work out really hard. We have the impact of the treadmill that reduces, the loss of bone density. But now we want to look at what happens to the internal structure of the bones. And so one of the experiments that we were involved in is looking at that. So, science and data collection and all that's pretty interesting because you collect the data today, but it might take years before you know the results. So that's one that we're looking forward to learning more about.
And I can tell you something that was kind of interesting that on a previous flight to ours that I think there's hope it turns out to be fruitful is some lung tissue that was grown on the space station. There's some hope that that might help in the fight against cancer.
My name is Oliver, and do you take a bath? And if you do, how do you?
So no, you don't take a bath.
Yes. 6 months, no bath.
But we do have to keep clean. You can imagine if you're in a confined space with 5 other people, it's really important that you try to make it livable for the other people as much as possible. We actually we have a potable water dispenser that can dispense, I'd say not really ever cold water, but ambient temperature water and hot water. And we've got a soap pouch. I think we get one of them a week. Is that right?
Every 2 weeks.
Every 2 weeks.
But we have the towels.
So we could inject hot water into that, and then once you put a straw in there with a valve on it, you could squirt soapy water onto a towel. There's also a hygiene towel that comes pre-embedded with soap. We could rehydrate that towel with hot water as well, and we use those basically to kind of lather up and then grab another towel to lather off.
Then we have like a rinse-free shampoo, so you put that in your hair and you don't have to worry about rinsing it out. So, hygiene is super important up there, and working out a couple hours every day, you're taking a shower at least a couple times.
Well, you guys, these questions have been amazing. Unfortunately, we're running out of time, so we have time for one more question from the audience.
Hi there, Sean Tully from Northrop Grumman. Now Northrop Grumman. If there's one thing you could tell the visiting vehicle providers, something you could change or add, what would it be? And I am taking notes.
I can tell you one thing not to change is make sure it stays just as stable for that robotic capture, because it was primo. It was much easier than the simulator, and I was very happy for that. Something to change.
I would just say when you design something, and this kind of goes to everybody who wants to be an engineer, is sometimes simple is good, and to keep the operator in mind, because if you have a way to mess something up, the astronauts will figure out how to do that. So it's really important to keep the people that are going to use it at the end. While engineering-wise it might seem like a good idea, but just try to keep things as simple as you can, and that will help us out kind of at the end of being the end user of it.
Yeah, I would say one of the more challenging things about visiting vehicles is that cargo transfer process. The more simple it is, the faster it'll go, and the more exacting it'll be done right.
But thanks everyone, you guys were awesome.
Thank you guys. Before you run away, I actually have a question for you, because it's a really exciting time to be at NASA right now. We've actually got this amazing exploration campaign and these plans to go back to the moon. So, given the chance, would you guys go?
Yes.
Yes.
Absolutely.
Easiest question of the day.
Excellent. Well, can you guys give me one more round of applause here for our amazing guests today?
Thank you. You guys.
Thank you both for your service to NASA.
Thanks.